All right. Engine basics.
Welcome back to podcast number 1 with Keegan and Caden.
Yes, that the car guy. So we're gonna be going over engine basics. It'll be a two-part, little thing. Keegan will explain some. I will explain some. Basically, some people may explain better. Keegan may explain one thing better than I do, and it will just help us grow better knowledge and you grow better knowledge. Any answers or questions, or any questions or answers, please let me know in the comments. Or anything you guys want to know, or anything you guys do know and want to share to us. We would love to take it and learn some more. So, and that further ado, let's get right into the first slide. Boom. The different block layouts of engines. So first we got the V shape.
And then we have the inline engine. And then the VR and the boxer. So V-shape engines. The only thing you're really going to know or you need to know about V-shape engines is there's two banks splitting them. So they're always going to have the same amount of cylinders on each side. Actually, no, I take that back. There is V3s. I don't know about V5s, but all I know is that there's two banks and there's basically most commonly there's going to be the same amount of pistons on each side. So let's take the V10. There's 5 cylinders on each side of the block. Kane, do you want to explain the inline engine?
Yes, I would love to. So basically, with the inline engine, it's literally so imagine so the inline was basically created to conserve space. So if you look at the V shape, it has cylinders on both sides. The inline is basically that, but just chopped right in half. You only have it's one nice camshaft, and the cylinders go all along it. It is one of the most simplest engines, the less moving parts, so it's going to have the less amount of problems because it's smaller, less moving parts. And with the inline, there is many models. We have actually one of the first inlines ever made was an inline 1. It was in one of the very first mass production cars that only had like a top speed of 34 miles per hour. But and then they made an inline 2, and then an inline 3. And then also they made a inline 4, which is most common, which you would probably see in your everyday Kia, Nissan, whatever. You'd probably see a nice inline 4. And the thing about inlines is that an inline 5 will run smoother than an inline 6 and an inline 4. And if you want to know this is the math equation. I'll pull up a quick little Google Jamboard real quick for you guys. Oh, yeah, you guys got a little sneak peek at the next slide. But Google Jamboard, so basically what the math equation is going to be is it's going to be, I think it's 360? Wait. Yeah, full rotation is 360, right?
Think so.
Alright, yeah, so you're going to do 360. And this is how you find the duration where the piston will not fire. So you're going to do 360 divided by how many cylinders you have. So let's say it in a V4, you'll divide it by 4 and minus by 180. And if we solve that real quick, you would get pull up the old calculator because I'm kind of, I don't got that super good math skills. You'd get Wait, I think I did that wrong. 360 divided by 40, and then minus 190. So that's how you figure out the duration. But if you go for let's say for a V5, for an example, or not a V5, an inline's 5, you will see that if you divide it, a minus 180, you'll get 360 minus 5 minus 180, and I don't think I'm doing the math right, but it should equal a 36 overlap. So I'm pretty sure that's the equation, or it's a little bit of a different equation. It should be that. I'm not the brightest crayon in the box, but yeah. So basically, It's either that or like a 380, but you're gonna divide the full degree of rotation. The full degree of rotation divided by the amount of cylinders minus 180, and I'll give you the duration of firing. So like a V5, not a V5, an inline 5 would have a 36-degree overlap, and that's why it's better than a V6. Overlap means basically when one's coming down and the other one's already firing, which causes for a nice smooth ride. And Keegan, if you would like to explain the VR.
Actually, I'm gonna point one more thing about the inline engine. Back then, when they first made the inline engine, if you're looking at it right now, those counterbalancers, those huge pieces, it looks like like metal flaps on that crankshaft there.
Yes.
Those that was created because when they were making these engines, I think the inline 8 or the inline 10. What was happening is all those pistons rocking that crankshaft really messed it up. So
It was given
they
the
made those.
crank a it was given a crank a jump rope effect, which is making it very making it not stable.
Yeah, it's just not good for engine performance. So they made those metal flaps or counterbalancers to help with the smoothness. And yeah, we're gonna move on to VR engine. Okay, so VR engines, they are a little weird. Not many models and cars actually have them. But so this is basically how it is. You got your block, but then the pistons, I don't know if they're in banks or not. I think they are. There should be two, since it's like a VR. Um, the pistons are at a 15-degree angle, and I know that's exact. I researched that. They're exactly at a 15-degree angle on each side. Um, I have absolutely no idea why they made that. I guess it was just a smart invention made by some guy or girl. So, yeah. I say we move on to Boxer unless you have
Well,
anything else to say about the VR.
with the VR, actually the reason why they made it was because they liked the inline and they liked the V. Hence the name VR. It's because they wanted to combine the V-shaped engine with the inline. That's why. So the V stands for V-shape because it has a little bit of a V shape, but it has the inline, and the word R in there. Actually, it's a German-made product. Germans made it, and I can't think of the word, but the German word that means inline starts with an R, so that's what they called it VR. They were trying to combine the V-shaped and the inline together.
It makes sense. I mean, really. Um, I think that wraps it up for the VR engine. Don't you agree?
Yeah, I think it wraps it up pretty well.
Now, Caden here is going to explain the Boxer engine.
Yeah, so I don't know a bunch about the Boxer, but imagine it's basically literally as basic as it gets in the thing. It's literally, if you take your cylinders, they're flat coming out the side. They're most commonly found in Subarus. All the Subaru fans out here. They're most commonly found in Subarus, and I'll have Keegan take it away from here because I know some more stuff about them, but I'm not 100% sure if my facts are right.
Since they're laid out flat, it is exactly at a 180-degree angle. Which obviously, if it's laid flat, I think I really don't know why they made the Boxer. I guess it was just a really creative design that they had.
I was reading. It's meant for something to help with the fire. I can't think of it off the top of my head, but yeah, it's something they made it, which just for like the ride, like how like with the inline and the V. It's just
Right.
something like that. If you guys know anything about the Boxer, comment down below. Or if you guys feel like we didn't explain the Boxer enough, we will do our research and make a full video just on the Boxer. Or like, just tell us something that you guys want to deep discuss. We'll have a deep discuss about that part. If you guys
Oh,
want.
you know what? I have one more thing. Now, this is just my idea. I really don't know. Gravity is always pulling downward, so picture how the valves are. Maybe it might help pull an air-fuel mixture because of the gravity coming down on it, plus that vacuum effect from the cylinder.
Yep.
There's probably many ways that'll. I don't know. It's just. I guess it's a creative design.
Yep. All right, and now we're just gonna have one of Keegan's favorite things right here to go with some of the engine types. We got the
Overhead.
overhead valve, over
Uh, overhead cam and
overhead
then dual
cam.
overhead cam.
Yep, and then the rotary. And guys, there are some more engine shapes. There are the U engine and the W. Basically, if you guys want me, I could put another video in there about them. They're nothing real special. They're not real popular. The W was basically two. It was basically two cylinders. Those ended up being like four cylinders, and it's basically, so if you take the V engine block and how it had two cylinders on that one area, it was basically four. Or there would be three just to make a W shape. And the U engine was two cranks. But yeah, they were not the biggest succeed, but I may not be telling all facts, but if you guys do want us to let you know about the W and U shaped. And then there's another engine where the pistons come together. If you want to know about that one too, just comment down below. We'll help you with that. So Keegan,
The only reason why we don't really know much about W and U is because they're not common. They really aren't.
no, they're not really that common. But if you guys would like us to do some research, we could and explain them to you guys. So now I'm gonna have Keegan take it away with the overhead valves.
Okay, now I have a perfect example for you guys watching. Now, you ever see those really old 69 Chargers or Challengers? Anything that it goes blah 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 blah. That is an overhead valve engine, and they call them lumpy cams because the camshaft is um I don't want to say on top of, but it's a little over the crankshaft. And what happens is those lobes push on these little tappets here, and basically it sends up the power, sends up all that energy through the push rod, lifts up that little rocker arm, and then pushes down on the valve so it can either let spent exhaust gases or air fuel mixture into the cylinder. And yeah, that's all it really is to it. Um, what do you call it? Those lobes, literally, they just lift up on those tappets there. It lifts up. I don't know. It's very simple. I mean, really, there's not really much you can think about to explain it. Literally, camshaft, tappets, push rods, rocker, and then your valve configuration there. Um, Next, I'm gonna explain the overhead cam slash dual overhead cam. Okay, this is a lot more simpler, and believe it or not, it adds more power because it's so much more direct that it can send that power so much easier. Um, and I chose this picture
It explains
because
it very well.
it does, it really does. So picture your left side as your intake valve, and the right side as exhaust valve. Now, I like these letters a lot. Um, so that yellow part right there,
It
that
shows
is
the
what it's
lobe.
called. Yep, that's your lobe.
It shows it really well.
It does. It really does. And if you don't really like the colors, just look on the right side, really. Um, that whole blue area is just your camshaft itself. So that lobe pushes down on that like valve retainer configuration there, like with the keepers and all that. It literally just it turns and it pushes down on the valve. It's so simple yet so effective.
Yes.
Um, and these camshafts have cam gears or camshaft gears that are driven by either a chain or a belt, which is connected to the crankshaft pulley, which that's how it all gets started. And really, that's all it comes down to is that. That's it for the overhead cam slash dual overhead cam. Oh, actually, no. One more thing. Dual overhead cam. I just explained the overhead cam. Now, DOHC is basically if you have two valves in one cylinder. So you're gonna have um, two camshafts working with one cylinder. all the way through. So you're gonna have two lobes pushing down on the two valves on the right side, or exhaust or intake, and then the same for the left. And the two valve configuration is very important because just one valve, it's pretty good. It's really good. Except with two valves, you're letting more charge or air fuel mixture in. And with the two valves for exhaust side, you're letting more out. More power, really. It's
Yes.
moving faster.
Okay, now
Um,
Keegan's gonna explain the rotary because basically what the rotary is, it's a, like we all like to call it, the Dorito with no cylinders,
yep.
and it's let's just call it a Mazda thing. We'll let Keegan take it from here. Uh, it wobbles, it rotates, it's a Dorito.
Um, so the reason why that picture has Mazda on it is I'm I'm quite positive. Correct me if I'm wrong in the comments. Um, they're really the only ones that have used the rotary or the Dorito engine. And most commonly, a fan favorite from Japanese productions or Mazda, the RX-7. Now, the RX-7 and I think the RX-8 has it. R for the rotary, obviously, RX-7. Um, they use rotaries, and boy, do they sound cool. I mean, I'm not even gonna lie, they do sound really cool. Okay, now into how it works. So that gear you see in the center there, not the Dorito itself gear, but the one in the center.
Oh,
What
I'll
happens
circle
is,
it. It's this gear right here, guys. He's talking about.
so what happens is they're always going to be connected. Now there's a crank on the other side of that gear, which sends power to your wheels and all that. Um, Basically that Dorito rides those gears and it just keeps turning and turning. There's always going to be teeth connected to teeth. It all comes down to. Now, if you see on the right side of that picture, um, rotaries always have two spark plugs, and the reason is because sometimes they don't have enough compression to be able to heat up that air fuel mixture enough, so they have to have two spark plugs. And if you're noticing, this is such a wide, this like huge big space on the right hand side. That is